Yeah, so I'm Frank. I work for a company which is called Databricks. I focus on data and AI. I have a history of doing like anything large-scale data, large-scale compute. I live in the other city, which is not Berlin, which is like the one with the mountains and the pretzels and the beer. I used to work for AWS. I used to work as a software architect. And yeah, I think you're not here because of me, you're here because of the topic. I want to point out a couple of things because I think they're interesting. Forget about the left-hand side of, maybe not completely, like when people think about Databricks, they often think like we're like the tiny company, and sometimes they Slack me and say, hey, can you put me in contact with someone who's working at big data and engineering at Databricks? I'm looking for a job. And then I tell them, look, there's 8,000 people, so like much bigger than you think. What I want to shift your focus is the right-hand side. Databricks, or actually the people working at Databricks, is the original creators of a lot of open source frameworks. Obviously, I'm biased, but I think Spark is one of the most important frameworks these days in big data. There's something now that was something just open source last week. I'm going to talk about this intensively, which is called declarative pipelines. Then some of you might know MLFlow. Delta Lake is the underlying foundation, one of the major table formats for lakehouses. Then there's DBRX. It was our own LLM. We built this, I don't know, it feels like a year ago. It was probably a bit longer than a year ago. I put us on the hit list of these LLMs for, I think, 2 weeks or so. It was more like, we can do it. And then there's Unity Catalog, like a unified governance layer, which you also see in my demo, but it's not the core focus, and it's also open source. I know that some folks always like being super allergic from, company stuff versus open source things. I think Databricks is really good in open sourcing things, but it's not the main objective. We don't want to churn out as many open source projects as possible. We literally want to solve like the big problems from like 10,000 customers and like really the customers with the biggest amount of data, etc. And then very often, don't quote me on this, but very often with Databricks, the question is not, do we open source something? It's more like, when do we open source something that is available? So one of the things where I personally never thought we would open source that is Unity Catalog, because it's kind of seems like an integral part in the Databricks platform, and it was open sourced last year. Same thing for declarative pipelines, maybe. Anyway, we come to this. Have you ever been to one of these photography exhibitions? I'm a big fan of photography. If you go to such an exhibition like, like Wildlife Photographer of the Year, or like Nature Photography, and you read about like the behind the scenes from, the prize winners, number 1, 2, and 3, they all tell you a story like how they spent 1.5 days lying in the snow. It was ice cold. It was raining. It was minus 10 degrees. And then finally they could take this picture. So there's always this story of suffering. It was so hard to take the picture, to really understand like, okay, they finally took a picture of this rare bird, but they suffered 1.5 days. I brought this picture, which shows the Milky Way. I took it. And talking about suffering, I was sick to death. Like I was altitude sick. It was like 5,300 meters in the Atacama Desert, which is, I think, slightly higher than the base camp on Mount Everest. If you have never had altitude sickness, you don't want to have it, I promise you. I don't want to tell you the details because this is just after lunch, but trust me, you don't want to have this. Anyway, I took this picture and I brought it to you to illustrate a point. And the point is the night sky is not static. And then you probably say, well, Frank, we know that. We have Instagram and we've seen these animations where you keep the Earth still and then you see the stars moving. But actually, it's the Earth rotating around the sun. Well, not static. I mean, actually, there's much more happening than just this virtual movement. There's a lot of things happening on a very short time frame, and there's a lot of things happening in a spectrum that we don't see with our eyes. If we could see them, it would look like this. That's an animation from NASA where they show you gamma ray bursts. So it's small gamma ray, it's not small, it's gamma ray explosions in the sky. The yellow dot is the sun. And the whole animation is for a whole year. So if you speed this up for a whole year, you see this in the purple flares, the purple circles are those gamma ray bursts. These gamma ray bursts, they happen all the time, but we don't see them with the eye. And actually very interesting if you have someone in your family or in your friend circle of friends who knows about astrophysics, who's an astronomer, you can ask them and they will probably tell them, yeah, there's like two kind of these GRBs, gamma ray bursts. They're the short ones, like typically shorter than 2 seconds. And they happen when two neutron stars merge. And then there's the slightly longer ones. And slightly longer means like 10 seconds, maybe 30 seconds. And that's typically the collapse of such a massive star, which is often like 30 times the mass of the sun. And there's satellites out there which try to capture these events. And the interesting thing is actually, for a long time, we didn't even know they exist. So for a long time, nobody knew those events exist. And it was during the Cold War when we had other satellites where we tried to monitor like the secret tests of nuclear weapons. And then at some point, we had these satellites in space and people said, look, we definitely know that, some other country is not doing a test, but we pick up these signals. Where do they come from? And they realized they're not coming from the Earth, they're coming from the other side. Anyway, the more pro level of doing that is this SWIFT satellite. And I want you to focus on the right-hand side where you see just the size of the satellite. I think there's like 4 people in the background of the satellite working on something. Then something interesting is the picture at the bottom. It's such a momentum wheel. So those satellites, they reorient themselves. They try to shift and rotate towards such a gamma ray burst. And there's a couple of instruments in the satellite. I'm telling you this just to remember for later, because we also see this in the data. Just remember the abbreviation. There's BAT and this X-ray telescope, the XRT. And there's something with UVOT. That's all to take away from here. Okay, and this SWIFT satellite, it's real. I can show you. It's actually right here. If you go to this satellite tracker 3D and you type in SWIFT, and you click on SWIFT, then you see the orbit of this SWIFT satellite. And then it's a little bit of, luck in really finding where the satellite is. And yeah, you can play around. I recommend you just check that out yourself. It's written by a super cool guy, that tool in Poland. We're in contact. He was like super happy that I'm showing his tool in conferences like this. Anyway, let's go back to, where are we? To my slides. So this is the SWIFT satellite orbiting around Earth and picking up those signals. And if such a gamma ray burst happens, it looks like this. And it was actually one of the biggest one they ever picked up. It was so big that like they couldn't really capture the magnitude of the energy. If you think about it, the energy is like the energy that the sun burns in its whole life during a few seconds. So if you think about all the sunburns you ever had, if you sit in the sun for 30 minutes, 1 hour, like all the energy from all the sun during the whole life of the sun in 2 seconds, this is what happens. And remember the rule I gave you, like less than 2 seconds, more than 2 seconds? This one lasted 10 hours. This is when the universe says, you with your, rules of thumb, well, it was just wrong. The things you maybe don't understand. So this one lasted 10 hours and with a 10-minute initial burst. Right, so we have all this data and it's like super interesting for astronomers. And if you think about this, that was like 1.9 billion years ago. And it's like 2.4 billion light years away. So the universe is expanding. This is why it's further away than the time. But if you think about event time versus ingestion time, this is like super old until we pick it up. And it's like maybe the application with the worst latency ever that you will see if you think about, messaging latency in Kafka and streaming data. This is not all, We have these satellites picking up those gamma ray bursts, but what astrophysicists really want to know is having this multimodal approach. So there is more than these gamma ray bursts. There's also data coming from neutrinos. Now, neutrinos, it's in the name, they're very, very hard to measure. So they typically cross the Earth without any interaction. So if you think about maybe the drink you had last night in the hotel bar, you had these tiny ice cubes. So what the researchers did, they took a real cubic kilometer of ice, like a cube with 1 kilometer, and they put like 5,000 detectors around them, so-called DOMs. And this makes it possible to pick up these signals. And then they have these signals from the ice cube, and they have the signals coming from space, and they want to combine them. And this is what gives them interesting data to draw conclusions about, the Earth and the universe. Right. Now, if I would ask you, okay, now you have all this data, streaming data, it shows up like, maybe not that often, maybe just like once every few minutes. The neutrino data, maybe once, a couple of them every second. It's kind of IoT events, isn't it? How would you build such a system? Well, if you ask this to an undergrad class, they would typically say, well, doesn't it sound like Kafka? Would that be a cool application for Apache Kafka? Well, yes, why not? But the answer is, how many public Kafka servers do you know where you could just, go and get the data from? So if you wanted to build such a system and also make it available to other researchers globally, how would you build it? The answer is, well, it could be Kafka, but it's probably not, because I don't know any other public Kafka server that would be around there. The answer is, well, NASA did exactly this. They said, well, we don't care if you don't know any other public Kafka servers. They made a Kafka project. It's called the so-called GCN project. And 2023, I was like super lucky. I was speaking at Current, which is the Kafka conference in the US. I think it was San Jose. And I always heard about NASA having such a public Kafka server. And Judith Rasmussen, she was having actually the slot right before me, like today, just before me. And she talked about everything I told you, like what's happening in space, just like 10 times more detailed and probably 10 times more correct, to be honest. And then she said, look, the thing is, we pick up these signals, and then there's telescopes on Earth that want to observe such a gamma ray burst. But they have an agenda, they have a schedule, like your children at school have a schedule, like 1 hour of math, 1 hour of, biology. And those telescopes, they're like super slow to move. So they get from that signal, which they pick up from a Kafka topic, they also get a merit value. And that merit value is a probability of how likely it is that this event is like super interesting for them. And then they can decide, you look like now I'm pointing to the top left and I get something with a merit value, and they're always between 0 and 100, like a merit value of, let's say, 55. Is it worth it moving to the top right or bottom right? That's basically the decision they have to take. And I mean, once you have seen them, like those big telescopes in Hawaii or in Chile, wherever they are, you understand that it's not an easy thing to move them. So that's the kind of thing they do, and this GCN really exists. It's a public Kafka server, which is actually having like hundreds of different topics. So once I heard this talk, I couldn't really talk to Judith because I had to set up my own talk. And then I knew that, they use Kafka, they have hundreds of different topics. And Judith was talking about all the cool things happening in space. And that's the topic, and that's a list of topics. And I was like, okay, but guys, this is like, the topic is like 5%, but these 5% is like what makes it interesting. And then what are the other 95%? Like, how do you get to the data? Can I get to the data? Can I play with this data? Can I visualize the data? What can I learn from that data? So after the event, a few days after the event, I thought I want to know more. And then I thought what can I do? Well, the topics are public, but there's 200 of them. And well, you can guess they're all full of floating point numbers. So it's not a cool story. It's not nothing that brings you here to Berlin Buzzword. So I thought let's just send them an email. I had the name. I thought what could go wrong about sending an email to NASA? It's a bit like Steve Jobs always says he was sending an email to Hewlett and Packard because he needed some transistors for his first project. And they didn't say no. So NASA didn't say no. On the contrary, I was like, you don't need to help me. All I need to know is like, give me one topic that makes a good story. And well, they gave me that topic. Now, the thing is, I told you I work for Databricks. What we kind of advocate is this Lakehouse platform. And the Lakehouse platform is actually the synopsis, the best of having a data warehouse and having a data lake within one platform. I think you heard about this. The idea is it's a simple platform. It is open. It's based on open source and open standards. And the way we implement it is on multi-cloud. So anything you do, you can just pick your cloud and run it on that cloud. Last week, and that's Michael Armbruster, he's the original committer, original creator of Spark streaming. Last week, this technology, declarative pipelines, was open sourced. And it's part of Spark now. So in Spark 4.0, you can use declarative pipelines. It's hard to see. I literally took that photo from like 40 meters, 30 meters away from the stage. But if you could read that, you could see there is like a create streaming table statement and a create materialized view statement. And these are the two components that I also used for this demo that I'm showing to you. So that's open source now. And then that's another blurry slide, so excuse the quality. These are all the open standards and open source platforms that the Lakehouse consists of. I'm not showing you this on an open source command line interface. I'm showing you this from the platform I'm using every single day, but you see you could build the same thing, actually almost the same thing, except the very last part of the demo, which is a bit the icing on the cake. You can decide for yourself if you like it or not. If it's worth it not going for the open source part here, you could build all this yourself using open source. Okay, so now the time is, we still have plenty of time. Now you should say, okay, a lot of talking, a lot of funny pictures from the stars. You told us how lucky you were meeting those folks from NASA. They helped you a little bit. That's all true. But how does that look like? Well, first of all, it's like super easy if you want to replicate this. So my message is like, not look how cool the things are that I did. My message is more like this Kafka server is out there. It's providing cool data. If you ever need like test data for your Kafka application, for showing maybe any of your products, be it open source or not, to your colleagues, why don't you use that? And I think that's like a core problem we have in if you work with data and streaming data. I go to many conferences and all the talks I see. These demos are not like super exciting. Like, what's the coolest really use case that they show you live? Like, very often you go to a streaming conference, but then you think like, I haven't seen any streaming data. People presenting stuff, but it's not streaming. Like, it's all made up, and the best they can come up with is some flag changing in some synthetic data set. Why don't you get a real data set? This is one. All you need to go is go to gcn.nasa.gov. There's a quick start. You click through that. You get these OIDC credentials. And then you're ready to go. You can set up your own tiny Kafka client and make that work in, I don't know, a notebook or like a Python program, whatever you prefer. You need one more thing. That's the other thing. It's like there's hundreds of topics, and they give you like terabytes of floating point numbers, so you still don't have a good story. You should actually tell the same story that I'm telling you here. I give you the topic name as well. All right, so let me show you what I did. Let me switch to my console, which is the Databricks Lakehouse. And let me zoom in a little bit. What you already see is like, the core construct that I'm thinking of is the data pipeline. So when Judith talked about the Kafka topic, I was like, okay, that's the last 5% of your talk. But the 95% that I want to see is how do you get the data from that topic, how you can process it, how difficult is that? Now, we actually at the company, we talk more and more about folks who want to use SQL for everything. Probably you're still at this thinking like, can I do this in Python? Which is also cool. Like, my background is more in development. So when I started like 4.5 years at Databricks, I started with Python. And now I realized everything in data processing, data pipelines, I tend to do in SQL because it's much easier. For a long time, the thing that was not possible within our platform in SQL was reading from message buses, Kinesis, Pulsar, Kafka. Now we can do this too. So when I started this tiny project, I thought, like, can I do it in SQL, like 100% in SQL? And the short answer is yes. The result is actually this data pipeline. It's music playing, it's not me, no. Okay, so it's this data pipeline. Remember, we had a streaming table in this open source screenshot that I took from last week from Data and AI Summit. So you see streaming table here, you see a materialized view here. Streaming tables in Spark 4 in this mechanism, which is called declarative pipelines, are a way to ingest data. So streaming data used for append-only sources. They write data to a table. That's why it's called streaming table. But it's append only, so you can't change existing data. It's not the perfect thing, you know, for complex aggregations. It's also nothing if you want to change existing previous rows in your data. You can't do that. But it's great for fast ingest exactly once from, you know, any append-only data sources. Materialized views, on the other hand, are a construct that lets you create a materialized view, which is like a pre-computed view on your data. In our world, we try to compute them in an incremental way. That means if you ingest it, or if you have like 1 billion rows in this view, and there's like 17 new rows coming, only those 17 new rows will be processed. But that's the idea of streaming table and materialized views, and you can obviously put them together. Now, that's the minimum pipeline you could have. Sometimes you don't even have to have 2 tables. But this is all I needed to get this thing running that I wanted to show you. Now, I told you it's easy. The thing is, it's easy until you start figuring out how to connect to Kafka. I already told you they're using this OIDC. Honestly, it took me a while to figure out all these SASL, JAS config things. This is all here, what you see here. Let me zoom in and remove this, and then you see more code. So this is all like the technical sugar we need to connect to Kafka, which is like, don't blame me for that. We have it. It took me a while to figure that out. And let's ignore this for a second, because it's just, you know, literally the connection string for Kafka. All the rest is literally create or replace a streaming table. That's the name of the table. And then I say, look, I want the offset, the timestamp, at the string value from this Kafka topic. And then that's the magic where we hide the Kafka access in SQL. It's called read_Kafka. So basically, it's a create streaming table, select everything from stream, read Kafka with the connection details. And that's all you need to do. And let me run this pipeline. So again, this is the Databricks platform. It's running on serverless compute. That means if it's a cold start, it typically takes like 1 minute to spin up. There is no cluster behind that anymore. We kind of abstracted away the Spark cluster, which was a big thing that we talked about last year. Let's let this spin up. I'm gonna turn this away. And then in the next step, I created a materialized view. Now, if I ingest the data in my streaming table, I see all the data coming in. I'm going to show you this data actually once it's available. And then I created a materialized view. And the materialized view, it looks even more complicated. The reason is when I ingest the data comes in as messages, as Kafka messages. You know, it's like an offset timestamp. But then I have the message. Now, the message for such an event that is put by NASA into this Kafka topic is a real message. When I built this application for the first time, it was like 2023, 2024. Everyone was talking about AI and RAG applications. I thought, like, what I really want to do is take those messages and put it into vector database and run some RAG applications. So I could like literally use like English language and query that data. And everyone, including in our company, they all talked about, yeah, you take the fact data, you put it into vector database, and then you query it. I'll show you why this was not a good idea. Actually, the pipeline was running. If I click here on that node, and if I go to What is it? This is that. Yeah, this is what I wanted to see. If I click here, you see the test, you see the data that was ingested, and you see offset, you see the timestamp, and then you see the message. Now, this message, if you look at that message, it has a lot of key value pairs. And actually, it's quite interesting because it contains a couple of things. So first of all, it contains a date. Then it contains coordinates, and want to come back to these coordinates. It's RA and DEC. RA is right descent. That's like a 360 degree. If I'm looking at this, it goes like, like this, like 90 degrees, 180 to 70, and then 360. And the DEC is like up and down. So I could go like 90% up or 90% down, or actually even more if I'm pointing backwards. And that's the weird coordinate system. And if you look at the data that I'm ingesting, it's actually not in degrees, but it's in days and hours, and here hours and minutes. And then they have like they norm it to year 2000. So it's like all this string, which is this huge coordinate thing. Altogether, this is like the whole message blob. And when I looked at this, I thought like, yeah, you know what? And that's actually the target name, what you observe here. So this is the name of the supernova, or the neutron star they're observing. Remember the merit value when I told you such a big telescope is not just moving around because it's like hundreds of tons of weight. It gets this merit value of 84. 84 is actually quite high. So 84 is like 84 out of 100. And that tells it, look, this is like something probably relatively important. Remember the image of that satellite I showed you, and I told you, just remember the instruments, BAT, XRT, UVOT. This is the data. So it's the real data coming from these satellites. Then they do weird things, like if you think about, modeling data the correct way or modeling events the correct way. They put in these messages, the sun position and also the moon position. When I saw this the first time, I thought like, come on, everyone could calculate this or look this up. Like they still do it, that's different thinking. The thinking is, if there's a huge telescope and it needs to shift from top left to bottom right, it doesn't want, some of them don't want to cross the sun, they would be blinded by the sun. Why aren't they calculating this but putting it in? Well, I don't know. It's just it seemed to be easier at that time, and then it comes with a lot of comments. Anyway, when I was there, I thought like, okay, now everyone is telling me if you want to do something cool, make a rack application, and then you can query this data. And then I looked at all these data sets, and the second one looks exactly the same, and the third one looks exactly not the same with the data values, with the structure. And then I thought like, okay, but this is basically, it's almost like a schema. So you have the columns and you have the values. Like, why would I put this in a rack database? And then I thought like, the real thing, if you're not doing this, I was tempted to say Gen Z approach. This is like, what is everyone doing? The real thing is like, you need to transpose this, you just need to pick out the column names and the values. And guess what I'm doing in this materialized view? I'm doing exactly this. Now, having such a blob and like doing this pivot operation and like doing this 90-degree turn, at least for me, wasn't that easy. So it took me a while to figure out the right SQL. In Databricks, we have something called Assistant, which basically is kind of what you know from Copilot. So you can type in, you get a lot of help with your SQL commands. This is the pivot table. And then at the end, if I just go to this node and I click on View Data Preview, it looks like this. So this is where I kind of picked out, that's the title, that's the timestamp. And then remember the RA coordinate, the DEC coordinate. There's still this lengthy format. That's the role. That's the slew time, which is the time when it will reorientate to the next event. It's doing this slew operation. And remember this momentum wheels that I showed you in the picture? because it's satellites and they don't have rocket fuel forever, and they still need to change the orientation, they have these spinning wheels. It's like what you can do on an office chair, and you just pull in your feet. So they have these spinning wheels that give them the momentum to slew into a new direction. And this is when this is happening, like the date and the time. So you get all this cool data, and you get the name of the target, which is like, one of the supernovas. So this is the columnar representation of this message. And of course, if you say, well, I'm not that obsessed as you, Frank, I could have written that in Python. I've tried the same. You can do it in Python, of course. But my goal was like, can I do this like entirely in SQL? I want to read from Kafka. I want to process these messages, and then I want to see if I can make sense of these messages. So when I had this, I was like super happy. And that was the data pipeline that I wanted to build. Right, and then, my original idea of 10 minutes, that's perfect, thank you. My original idea of, like everyone was kind of brainwashing me to like, can't you build a RAG application and make sense of this data? Kind of shattered when I realized, come on, now I have columns and values for these columns. I don't need RAG, I can write this in SQL, no? And I thought like, okay, what's the cool part of SQL? Yeah, I mean, that's a bit from the 80s, like, it doesn't get you into any conference and stuff. I could still do analytics, And then I thought like, and that's now the icing on the cake, which is not open source. I'm not saying not yet open source, but it's not open source, which is something that we do in the platform. So once you have these, any table basically, you can go here and you can go to Genie. Now, Genie is a system where you define a Genie space. Oops, and now I need to see. Don't even remember what was the last one. I think it was this one. Yeah. You define a Genie space, and a Genie space is basically just pointing at a table or a number of tables. And then you can ask it questions in natural language. So you can say something like, I can just click on these, but I could actually type the same thing. How many events did you see? And remember, the pipeline was running. It was ingesting a number of events. The thing is, if you access that topic, they kind of keep the events from the last 4 weeks. Basically, and it says like 3,333. That sounds like a bit artificial of a number. But you could also say, what was the first event? Let's see if that is working. Oops. Okay, it says 16th of May. So that was like, was it 4 weeks ago? Okay, let's check this. What was the last event? Now, obviously you're all tech folks, you can guess what's happening. It's taking the natural language and it's kind of searching the data, and it's like 17th of June, which is today. So it's literally the data from the last 4 weeks. Now, the thing is, everyone here knows it's based on LLMs. Everyone here knows, well, that sounds like a tool for the business folks. That's also how we position it. And then would you trust that data, if that's like, what's the ARR for the company for this year or last year? Would you trust financial data, for stock data, maybe for healthcare data? The answer is, well, you don't have to trust it. The cool thing is you can just click on show code, and then you see the SQL code. And then you can decide, well, does that SQL code make sense or not? I think it makes sense here, so I'm happy with this. There's one more thing I want to point out. If you remember the first diagram that I showed you with these purple flares, click, 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 and I said, like, this is what NASA built throughout 1 year. I thought, like, could I do the same? And the answer is, well, I have the data now. Could I just visualize it in that way? And if I go back to the data, you remember I had this long string, with this redundant J2000, and then it was like in days and hours and whatever. Like this is not really what does that say? 5 minutes. This is not really a format that I can work with. So what I did is I literally wrote a data science notebook. I was kind of using regex expressions, again, using our assistant to help me to get them right. And then I kind of extracted the number in degrees and in both degrees. And then I plotted this and I came up with such a plot. And I thought, like, probably this is the point where we need to say, this tool is fun for, basic SQL. But if you want more advanced stuff, you either need to prepare your data in a way that you just, remove all this extra syntax, or you write a data science notebook. And then I thought, like, wait, there's one more thing. What we can do is we can actually define instructions. So we can give this system an instruction, and we can tell it, I don't see them here. We can tell it by example what it's supposed to do. So what I can do is like, I can say, give me all the coordinates. By the way, the cool thing is I'm never telling it what's the column name. I'm never telling it, we need to do this or that. So let's see what it comes up with that. So it gives me the R, A, and DEC coordinates. And then I say, plot these coordinates. And look at this. This is what it does. It looks, well, it's a static snapshot, of course, but remember, like, when this was flickering. Actually, what I didn't show you in that initial PowerPoint, there was something in the middle. I can go back to this. There was something in the middle where we have no events, which is this orangey thing, which is the own Milky Way. So it's our own galaxy where we don't see a lot of these events. And come on, where are we? And you see the same thing in my, where's my Genie space? It's got lost. Not here. Hello. Oh yeah, and I think this is the same, this is the same construct. And you see it's like 90 degrees, 0 here. So this is the middle thing where you don't see anything plotted. All right, so that's the story. I have the source code on GitHub. I wrote a blog about this if you're interested to read it. And then, still need to find my slides. Damn, where are they? Oh, here they are. Okay. Okay, so there's a blog about it. There's the code on GitHub. The code is using Databricks declarative pipelines, but now it's open source. The conclusion is, I think you should give this a try. Remember, the complexity was basically because of the Kafka connection settings, but streaming tables, materialized views are super easy for creating data pipelines. You're one SQL command away from, accessing supernova data from NASA. If you don't have a better, example for your next streaming data project that you show to colleagues, use that one. LakeFlow is the platform that we built around it. Genie is the platform that we built for natural language questions. I think it's pretty good. You can see the code to make sure you get proper data. And then I want to close with a quote from Brené Brown. And she said, like, stories are just data without a soul. Thank you for being here. If you have any questions, I'll be around. I know we're very strict with the timing, so I don't want to overrun. Thank you.